third page.
Yeah, I've got the second page. She sent it. Got kind of a new nifty tool which allows me to write directly on the page. Yeah, I've always had it. I just didn't know I had it. So, let's talk about the 6 trig functions, starting with sine, cosine, and tangent. What is the sine of theta?
Opposite hypotenuse.
So what is it here? What is that ratio?
8 over 17, I think that's what it says.
Yes, it does. I can blow that up a little bit, but unfortunately it loses its, whoops, hold on. Loses its resolution. It's not quite high enough resolution to blow it up. So if you can make it out at all, let's work with this zoom level. What's the cosine of theta?
It would be 15 over 17.
Yeah, now notice that that 15 wasn't in there. So we had to solve this triangle to put that 15 in there using the Pythagorean Theorem. Okay, what's tangent of theta?
Tangent is 8 over 15.
It's cotangent?
The cotangent was 15 over 8.
Cosecant?
17 over 8.
And secant?
Is like 15 over 17.
The other way around. Secant is the hypotenuse over the adjacent.
Oh, my bad. I meant
Yeah, I figured you probably meant that. But you know your reciprocal functions, right? You know what the reciprocal of sine is?
yeah, I understand that.
Okay, good. All right, well, I don't know that we need to do every one of these, but let's do the second one just to talk about something. First of all, does your teacher require you to rationalize this in trig?
Yeah.
You sure? Because the new trend is to not worry about rationalization when you're learning trig. And that's because some of the functions are just reciprocals of the other. For example, let's look at 2. What is the cosine of theta?
The cosine is 3 over 58, and
cosine. So, ka, toa.
Okay. I think I just let me look at this again. So
what's cosine? Cosine, not sine. Cosine.
It would be 3 over root 58.
No. What's the adjacent side to theta?
Wait, you said cosine, right?
Uh-huh.
Oh, adjacent over. Oh, my bad. Okay, it would be 7 over root 58.
Okay. Now, the trend is to accept that answer and not insist that it be rationalized. And the reason is what is the secant of theta in this problem?
58, root 58 over 7.
Yeah, notice how much easier it is to come up with secant if we don't rationalize it. Now let's rationalize that. What's that rationalize? The cosine of theta that was 7 over root 58, rationalize it.
It would be like 7 root 58 over 58.
And now, based on that, tell me what the secant of theta is.
Would it be root 58 over 7 still?
Well, yeah, but let's pretend we don't know that. In other words, we've solved for cosine, and then we've rationalized it, and now we ask for secant. Well, if you had to work with that answer, gosh, you're going to have to rationalize it again, because you're going to flip it to get secant. And then that needs rationalizing. So you got to do all this rationalization, sometimes completely unnecessary. Whereas if you leave these answers not rationalized, then it actually works out better. And I'm not sure why math ever came up with this thing where you have to rationalize. All right, so you need to go over 3.
3, I think I'm okay with it because it's like...
Okay. Well, if you know how to do 1 and you know how to do 2, then you're going to know how to do 3.
Yeah, and this is like a homework thing.
Okay.
Like,
I know you need to get through the whole thing, so I don't think we should spend time on stuff that you know how to do.
Yeah, and I already did this. I just wanted to do it.
Okay. Let's talk about 4.
Right.
Solving triangles, solving right triangles. So they're saying that side is 18, and that angle is 50 degrees.
Yeah.
And they want you to solve for everything. Let me erase some of this other stuff that I no longer need here. First of all, by everything, I mean they want you to solve for angle A. So what's angle A?
Angle A is 18, or no, not angle A, sorry. Angle A would be like 90 plus...
90 minus 50.
Yeah, or you could just add them up and then subtract 180.
Well, it's easier to treat them as complementary angles and solve it by subtracting from 90. To add another 90 into it and make it 180 just complicates the arithmetic. So you want to know that the 2 small angles on any right triangle are complementary.
Yeah.
And that means they add to 90. Okay, so now we got all 3 angles, and we got this side. How can I get side B?
Side B, you just, like, you could do any trig, like, function.
Okay, give me one.
Well, because you're given, like, 18, you could do, like, opposite over adjacent, so tangent.
Okay, so you're saying the tangent of what?
Like...
Got to give me the whole equation. That's the only way you're going to solve it.
Every tangent of, you put a variable like O.
Which angle? It's not a variable. It's 50 degrees.
Yeah.
Okay, what is that equal to?
It's equal to opposite.
Okay, which is what? What's the opposite?
Opposite is B.
Okay, so it's equal to B divided by what? Remember that trig functions are always taken of angles and you get ratios. That's the thing. You take trig functions of angles to get ratios. What's the denominator? So, okay. So B, therefore, is 18 times the tangent of 50 degrees, and that's a number you're going to get out of your calculator. So get the, hold on, can you still hear me?
Yeah. I'm on the phone, remember?
Yeah, no, I know. I got an incoming call. Cannot believe I cannot figure out how to handle incoming calls. You still there?
Yeah, I'm here.
Okay. Yeah, I mean, incoming calls used to, ever since I've got this new phone, I cannot figure out how to handle an incoming call. It doesn't pick up my finger touch when I touch it. So what does B end up being? If you put that in your calculator. How much?
21.45.
So 21.45. Are you supposed to round it off to 2 decimal places?
I don't know, it's just, yeah, it's better that way, more accurate.
Well, usually the teacher will tell you.
But the book doesn't really tell you, so...
No, it doesn't. And that's why it's kind of dependent on the instructions and the teacher. Okay, now we've got two sides and all three angles. The only side left to solve for is C. How are you going to solve for C?
So basically, for C, you can just go like opposite over hypotenuse, so sine, or no, you do sine.
Okay, give me the entire equation, Sam. That's the secret of these. Is you've got to write an equation that you're then going to solve.
It would be 21.45 over...
Hold on. Sine of what? Remember, you're always taking trig functions of angles.
Right, it would be sine of 50.
Okay, that's what I'm looking for. Sine of 50 degrees equals what?
It would be 21.45 over C.
Right. And there's only one unknown there. In other words, you get that number out of your calculator. So C is going to be 21.45 divided by the sine of 50. You see that? Doing the algebra?
Yeah.
Okay. And now you solve that triangle. And that's all you have to do to solve any of these triangles. Is to solve for, use whatever trig function you need to solve for the sides. Let's do at least one more. Again, I don't think we're going to need to do all four of these.
For these ones, could we maybe do all four because I...
Sure. No, if you want to do all four, we can do all four. So, angle A, notice the angles are the big letters, the little letters are side lengths. So, that's 33 degrees. Now tell me what angle B is.
B is 33 minus 66 or 67. 57.
When you're doing complementary, these two numbers always need to add to 8 as long as there's no zeros involved.
Yeah.
Not 9. That's a common mistake. Everybody wants to make those add to 9. They don't add to 9. These add to 8, and then the two remaining numbers add to 10. That's how you get 90.
Yeah.
Okay. All right. So now they're telling us that side C is 12. So give me the appropriate trig function to solve. We've solved all three angles, and we have one side. So we got to solve for B and A. So make up a trig function and give me an equation to solve for one of them.
Okay, for A it would be, A it would be, you can do tangent, so opposite over adjacent, which would be,
give me the equation.
Tangent of 57, 57 over...
Hold on. Equals what?
Equals, B is, what did I put for B? B over... Wait, did I get it?
Well, here's the problem. Here's the problem with using the tangent function. You're ending up relating two variables that we don't know what they are. I cannot solve that problem because I've got two unknowns. Okay? So you want to find a trig function that's going to use that 12. So what trig function of what angle will use that 12?
It'll be sine.
Give me the entire equation. Sine of what?
It would be a 12 sine of 50.
No, give me the equation. Don't solve it in the middle. Give me the equation and then solve it.
Sine of 57 equals B over 12.
Okay. Now, Give me an equation that solves for A.
Here, one sec. I'm just writing down the answer.
Okay.
Okay, and, for that, it would, for B, you can find, wait, we solve for B.
We did, but it doesn't matter. I don't care what the solution is. I just want to make sure you can write the equation. Okay? For A, what equation is going to work really nicely? What relates A and the side 12?
You can do cosine.
Okay, so give me the equation. Cosine of what?
Cosine of 57 equals, was B. B was...
No, it's not B. Cosine uses the adjacent side over the hypotenuse.
All right. Okay, the adjacent side would be, it would be A. So then you just do A over 12.
That's right. And there's only one variable there, A. So you're going to be able to solve for A and B, and that finishes the problem.
Yeah.
Okay? So, like I said, I don't think we should waste time coming up with the precise numbers. That's a calculator problem. Okay? Let's get these set up so you know how to do them.
Okay.
So let's do 6. You're going to have to help me. A is what? I can't read that.
6 is 10. A is 10.
A is 10 degrees, which makes B?
B would be, that would be 10. That means B would be 80.
Okay. Now notice in this case that 1 and the 8 add to 9 because both the other numbers are 0. So as long as the other numbers are 0, they're going to add to 9. But if the other numbers are anything other than 0, they're only going to add to 8. Just remember that. It makes for fewer mistakes. Now, the one side they've given us here is 3A. Okay? So, give me an equation that allows me to solve for either B or C. I mean, just start the thought process you should be having here is what equation will relate 3 to B and C or C?
B, okay, to find B, you could do the tangent of 80. Tangent of 80, B over 3.
Okay. That's easy enough to get. You good? You good with me going on without coming up with numbers? Or do you want me to take the time and let you put this in your calculator?
No, it's fine. I can just write it down.
In other words, we can speed up a little bit if we don't do that stuff. Now solve for C. And the important thing in understanding these is just to set them up. I know you can do, algebra and arithmetic and use your calculator. The key is getting these equations. So we've solved for B. How would we solve for C?
To solve for C, you can do the cosine adjacent.
Okay.
Cosine would be cosine of 80 3 over C.
Okay. Now, there is one thing let me mention. Had you solved for B and given me an approximation, in other words, rounded it to 2 decimal places, and I'd have written it in there, and then you decided to use a different trig function that relates B and C, you're liable to get some round-off error. So to figure out that third side, it's really much better to use 3 and C, not B and C, even though you know B at this point, because we solved for B. But you know an approximation of B. You don't know exact B. So it's better to use the sides that are not approximated yet, which are 3 and C.
That makes sense.
Okay. So let's do this one last one. B is 71 degrees. What's A?
Okay, A will equal, angle A will equal 29.
What's 2 and 7 add to?
What?
What's 2 and 7 add to?
2 and 7 equal, right.
They got to add to 8, not 9. So it's not 29, it's 19.
Yeah, that's just,
In other words, 1 and 7 add to 8. That's what you want. That's where you want to start. They don't teach subtraction that way. They teach you to do the 9 first. But the way I subtract is I start with the tens digit. Okay? And then they gave us a C that's a decimal. Great. Let's complicate the problem. 2.3. Okay, what's the next step? You got to solve for both b and little a. I don't care which order you do it in.
okay, so for little b, you can do tangent of...
You cannot do tangent.
Oh, right, you can't do tangent.
Because tangent's going to relate b and a. So tangent will give you two variables. You won't be able to solve that. So you've got to use a trig function that uses the 2.3 in it.
Sine of 71 equals, it'll be b over 2.3.
All right. And to figure out a?
For a, you can do, which one, cosine of 71 equals adjacent over 2.3.
The adjacent is which?
The adjacent is
A over 2.3. And then you can solve for A. Okay? So that's the way you want to think when you're doing trig. Is when you're solving triangles, you're always looking to figure out which trig function is going to leave you with just one variable. Okay? It's not tangent, because we don't know b and a yet. Once you figure out b, then you could use tangent, although you'd be working on an approximated number. But nonetheless, you could still do it. All right, so that's the secret to solving these triangles.
yeah.
You have not had the law of sines yet, is that correct?
Yeah.
That's correct? You have not had it?
Yeah.
Law of sines and law of cosines?
No, I don't think we haven't done that yet.
You've just started trig, is that correct?
Yeah.
Okay. Yeah, you haven't had it yet. All right. So the next one, I assume that says find one. Yeah, you got to be careful when you take these pictures with a flash. This is what happens.
That was my mom that did it.
Well, I know. I'm telling her also. Better way to do it is just put the page in proper light and use no flash, and then you don't get those blank spots. So find one positive angle and one negative angle that are coterminal with each of these. Is that 25 degrees?
Yeah, but the only one I want to do is 9 on this work.
Okay. Okay.
Like, I just want to make sure I did the radians right.
Okay.
Well, I'll just tell you what I did.
Okay.
Basically what I did is I just multiplied 14 by 180, and then I divided by 3.
No, that's really, let's talk about that. You could certainly convert this to degrees and solve it that way.
Yeah.
But there's a better way of doing it. And you want to probably, no time like the present, start thinking in terms of radians. Okay? So coterminal angles means that I can add as many 2 pi's to this as I want, and every one of them is coterminal. Okay? And what I want to do is I want to keep adding 2 pi's until I get a positive number. So we'll start with my minus 14 pi over 3, and I'm going to start adding 1 2 pi, which is 6 pi over 3. What's that give you?
Would that be 8 pi, negative 8 pi?
Negative 8 pi over 3. So there's one answer. They said one positive and one negative. And now let's add another 2 pi to that, which is another 6 pi over 3. What's that give you?
Negative 2 pi over 3.
Which is still a negative angle. So let's add another 2 pi to that. What do you get?
You will get positive 4 pi over 3.
That's your positive angle right there. So 4 pi over 3 is one. There's also a bunch more. I can keep adding 2 pi to this. In other words, every time you add a 2 pi, you just go into another coterminal. Instead of the unit circle, you're in the second unit circle, or the third, or the fourth. But there's the first positive one I ran into, 4 pi over 3. I had multiple negative angles that would have answered this question. Minus 2 pi over 3 works, minus 8 pi over 3 works. I could have even subtracted 6 pi over 3 to get minus 20 pi over 3. That's also a negative angle that's coterminal.
Right.
Okay, so coterminality is easy whether you're in degrees or radians. If you're in degrees, you're just adding 360 or subtracting 360. If you're in radians, then you're just adding 2 pi or subtracting 2 pi.
Yeah.
Okay, so you know how to do 10 and 11?
Yeah, I know how to do both of those.
Okay.
Yeah.
All right. Which one do you want to go to next? 12?
I feel like the ones 12 through 17, maybe I feel like I might have been doing that wrong.
These are actually pretty easy. Let's just talk about arc length. First of all, arc length is radius times theta if it's in radians. Okay, well, most of these are. If it's in degrees, then we're obviously going to have to apply the conversion factor for theta. And that conversion factor is pi over 180. So this is if it's in degrees, this is if it's in radians. And really the only one you have to memorize is that one. As long as you know what your conversion factor is. And you know that when you're converting from radians to degrees, you always multiply it by pi over 180. Ah, I got that. Yeah, no. If theta is in degrees, then we use the lower one. If theta is in radians, we use the simpler one. Well, give me the answer for 12. S is equal to what?
It would be 6 pi over 180 times.
Hold on. Let's not convert that. 6 pi over 3. We're in radians. Now, the 6 cancels with the 3, and your answer is 2 pi. That's the length. The arc length is in radians. Excuse me.
Only one answer, 2 pi over. Okay.
Well, let's do it the second way, just to verify. Okay? So the second way is the radius is still 6, but pi over 3 is a 60-degree angle. Now I got to multiply by the conversion factor, pi over 180. And lo and behold, yes, I get the same one. 2 pi is the answer. Okay? So, to me, it makes more sense. In other words, I had to do a lot more calculations on this second way than I did on the first. If you're given radians, then use the simpler formula, which is this one up here. Okay, for example, 13. What is S equal to?
It would be 10 pi over 6.
Yeah.
Which would be simplified to like 5 over 3.
5 pi over 3. 5 pi over 3. Okay. And now let's do 14, where they give it to you in degrees instead of radians. So what's your master formula for arc length? Oh, and excuse me, I didn't finish this problem. Let's go back and finish it, because they want not just arc length but area. Okay? And let's talk about how you find the area of a sector. In other words, here's a sector. This area right there. You with me?
Yeah.
Okay. The way I'm going to find that area is I'm going to find the area of the whole circle, pi r squared, and I'm going to multiply it by the portion of the whole circle that that sector represents. Well, let's say that that was a 60-degree angle, and I had a radius of 5. Well, the area of the whole circle is pi r squared, that's 25 pi, but now I'm only dealing with 1/6 of the circle. Why? Because it's 60 degrees divided by 360. So that's the way you always do the area problems, is you figure out the area of the entire circle, all you need is the radius for that, and then you multiply it by whatever fraction of the circle we're looking at. In my drawing there, 60 degrees represents 1/6 of the circle. So it's 60 divided by 360. And that's the way we would get that initial area. Now, in our problem here, let me do it relative to our problem, number 12, the area is of the entire circle is 36 pi, right?
Yeah.
What part of the circle is pi over 3? And the way you're going to do it is this way. I'll show you how to do it first. Pi over 3 divided by, what's the whole circle?
Like 2 pi.
Yes. So we're not going to switch to degrees. We're just going to switch to radians and work the whole thing in radians.
Okay.
As long as you know the whole circle is 2 pi, that's the same as 360 degrees. Well, now nice things happen. That cancels with that. This becomes pi over 6, which means the answer is, that's the area. 6 pi square meters for number 12. And it's definitely square meters. Area is always in square, whatever unit you're using. Okay, now let's do 13, the area. You tell me how to do the area on 13.
Basically, you just do, you do 2, like the radius times, like the angle.
Okay.
The radius.
Yeah, you can't give me answers like. Give me an equation. What is the area of a circle equal to?
It would be 10 pi or...
No, we're doing this one. We're doing this one right here. What's the radius? First of all, what's the general equation for the area of a circle?
It's pi r squared.
Okay, you got to know that to begin. Now, what's r?
2, so it would be 2...
So the area of the whole circle is 4 pi.
Yeah.
Now, what's the area of this? What part of the circle are we looking at with this angle?
We're looking at 5 pi over 6. So then you just...
Hold on. Divided by what?
divided by 2 pi.
Right. In other words, what we're looking for isn't that angle. We want to know what part of the circle we're looking at. And this is the fractional part of the circle we're looking at. Whatever that comes out to be. Looks like it comes out to be 5/12. Okay, so we're looking at 5/12 of the circle. So we're going to multiply 5/12 times 4 pi to get our answer for area of that sector. With me?
Yeah.
All right, now let's do 14. Let's do the first part. Did we do the first part on 14 already? No, we didn't. Because this isn't the formula we use. What's the formula I'm going to use for 14 because it's in degrees?
You're going to use the conversion one, the longer one.
Tell me what it is.
It
starts out the same. It's r theta.
But you put 180 on the bottom and pi on the top.
Okay, so it's times pi over 180. Okay, now let's fill in everything. What's arc length equal to on 14?
8.
Times
20.
Times pi over 180. And again, that comes out to be a number, some number of pi. Looks like 16/18, which is 8/9 pi. Okay, so that's the arc length. Now what's the area for 14? Start with area, not arc length. So let's erase all of that.
The area would be, pi r squared, which would be,
What's that?
it would be 64 pi.
Okay, that's the area of the whole circle. Now what?
64 pi, and then you can just use the area. You don't have to use radians because they give it to you in degrees.
Okay.
So you just multiply by the percentage of that to
Give me the ratio. That's all I care about. We can simplify it later, figure out what percentage it is. I don't need any of that. I just need the ratio. What is the ratio?
1/8 divided by 360.
Okay. Now I'll let you do the math. I don't care. There's lots of shortcuts you could take here. Or you could just plug this all into a calculator. This is the key. That's the ratio. I don't care if it's 1/18 or 7% or any of that. I just need the ratio to multiply by. Okay. Now, shall we do one of these? Keep going until you get one completely right?
Sure, yeah. Let's just do them all the way through.
Okay, let's do 15. Give me S. And the best way, Sam, to do all math problems is to always start with the general formula. Then you're just plugging in. Then it's easy. If you're trying to do the entire problem at once in your head, that's where you get messed up. Is if you start with the general formula, it's always just one step at a time.
Right.
What's the general formula, given that we're in degrees?
You have to convert it, so just be 220.
That's not the general formula. Give me the general formula. By that I mean r theta, what's the rest of it?
So that would be like 1 pi over 180.
Okay, that's the general formula for arc length. Now plug in what we have for 15.
It would be 22 times 220
times pi over 180. Okay? See, once you've got the general formula, then it's a piece of cake, just plugging in, that's all it is. And then you got to simplify that, but presumably you know how to do that. So let's get these all set up. Okay, now we didn't finish with 15. What's the area general formula?
The area general formula is like that pi r squared.
Okay, that's the area for the whole circle times what?
Times like the ratio is of the circle.
Give me the ratio.
The ratio for this specific one would be 20. It would be 220 over 360.
That's all I need. Okay. Now plug in what we have. What's R? So that's the area of the sector. So the only thing we need to plug in is R. R is 22. So it's 22 squared times pi times 220 over 360. That's going to be the area of that sector in 15.
Yeah.
Okay. Now let's do 16. Okay, let's do 16. What's the general formula for the arc length? There's a reason I want you to keep repeating this. Because by starting out every problem with the general formula, you're going to know that general formula by heart after about 3 problems. That's the key. The way you memorize it isn't by looking at your book and seeing what it is and then plugging it in. That's not the way to memorize anything. The way to memorize it is to keep testing yourself. See if you've got it memorized. So what's the general formula given that we're in degrees on 16?
It would be r theta pi over 180.
Good. Now plug in everything. What is it for our specific scenario?
It'll be 5 times 75 pi over 180.
Great. Now let's look at the area. Give me the general formula for the area of that sector or the area of a circle, whatever you like.
Pi r squared times the ratio.
What's the ratio?
The ratio will be 75 over 360.
Over 360, yeah. Okay, and then what's R?
R is 5.
Okay, so that gives us 25 pi times the ratio, 75 over 360. And I don't even try to simplify that ratio. There's no point. You know what I'm saying?
Yeah.
In other words, I could simplify it. I can clearly divide top and bottom by 5, but why take the time? Because most likely you're going to use a calculator at this point. And you're going to say 25 times 75 divided by 360, and then we're going to put that number next to pi. That's the area. Okay? All right. I think you're getting the hang of it here. Let's do one last one. 17. Sector. General formula.
The general formula is r theta pi over 180.
Specifically for our problem.
It'll be 12 times 160 pi over 180.
What's the units going to be on this? Are we in feet? Are we in meters? What are we in?
Millimeters.
That's what the units will be. In other words, whatever R was in, that's what S is going to be in. Okay?
Yeah.
All right, now let's do the area. Give me the area general formula.
Pi r squared times the ratio.
Give me the ratio.
The ratio is 160 over 360.
Okay, and R is 12, so it's 144 pi times 160 over 360. Like I said, don't spend any more time on it than that, because you know you're going to solve it using your calculator. All right, but one last word of note here. You do want your answer in terms of pi. You don't want to put pi in and then write the decimal answer out. You understand?
Yeah.
Okay. In other words, you do not convert pi to 3.14 here. Your answer is in pi. In other words, whatever 144 times 160, divide that by 360, that goes in front of pi. If that's 15 pi, so be it. If that's 15.2 pi, then that's what you got. But leave your answer in terms of pi.
And, I actually put it together wrong. 52.6 pi.
Let's see. There's nothing else. How about this pizza deal? Do we need to do that?
Yeah, let's do that.
Okay. Let me get it so I can read it. Let me expand that just a little bit. Okay, good. Now I can bring my drawing tool in. Decide which of the two pizza slices is the better deal. This is $1.50 per slice. This is $1.70 per slice. So how am I going to figure out which is the better deal?
Find which one has the bigger...
Well, find the area of each. It's not necessarily the bigger area because their prices are different. Okay. If they were both priced at the same thing, then it would just be a simple question of finding the bigger area.
Yeah, you can find the area of both of them, then you multiply it by the price.
Okay, we're going to call that 1 and that 2. So what's the area of 1?
It would be 6 pi squared.
Hold on. What's the general formula again? See, that's the problem with not starting with the general formula. Is sometimes you get it wrong. But if you start with the general formula, then you're just plugging it in.
Yeah. It'd be pi r squared times the ratio.
Give me the ratio. Don't just say the ratio. Tell me what the ratio is.
60 over 360.
Okay. Now, plug in the only thing you know, which is R.
It would be 6 pi squared.
The pi is not being squared. It's only the 6 that's being squared. So it's not 6 pi squared, it's 36 pi. In other words, if I write this exactly and plug it in, then I'm going to plug in 6, and that's the only thing that's being squared. And that equals 36 pi.
Yeah.
The problem that I saw with you is you tried to come up with R first, instead of just writing it as we see it. Now, you can turn that into 36 pi, and that's fine. That's what I usually do, is you want the number before the symbol pi. And this is 1/6, right? So I can actually do this without a calculator. The area of slice number 1 is 6 pi. Okay, so let's write that, 6 pi. It's funny that they're using pizza and talking about pi. Now, what's the area of pizza number 2?
Pizza number 2 would be 49 pi times 45 over 360. And then find the ratio.
Now that one you might need a calculator. I don't see anything that's going to cancel real nicely.
It's 1/8.
What's that?
So it's like 1/8, so I'll just put it in my calculator.
So it's 49, it's 49 eighths times pi, right?
Yeah.
What is 49 eighths? That's like 6 something.
Yeah, 6.125.
So 6.12 pi. So now how do we figure out the better deal?
You multiply both by the price.
Yeah, if you kind of want to figure out what the price per square inch is, well, this piece is 6 pi square inches, right? So let's go through this. The first piece is 6 pi inches squared. Now, if I divide that by $1.50 per slice, $1.50 per slice, then I get 6 divided by $1.50 is 4 pi inches squared per dollar. So that applies to that deal. And in the other case, I'm going to divide 6.12 pi by $1.70. Now I can tell right away that that's not going to come out to be as good a number. What's 6.12 divided by 1.7?
Equals 3.6.
So here, 3.6 pi per square inch, that's dollars. This one up here is 4 pi dollars per square inch. This one here is 3.6 pi dollars per square inch. The value is better with a higher value per square inch. In other words, clearly this deal, this 6 pi worth of pizza at $1.50 is a better deal than this 6.12 pi worth of pizza for $1.70. And you get it by just dividing. All right.
I think that's good.
Okay, so shall we go to the other document here?
Sure, yeah, it's only 3 problems. It's only 23 through 25 that he wants us to do on there.
Okay. (23 through 25). Okay, cool. This one, I think I'm going to do it using my, I think this will work better if I do this. In other words, I don't have a need to draw on there, but I do kind of have a need to draw the unit circle. Okay? So, if I have my unit circle with my coordinate system going through the middle of it, and they said given a point 4, 5. Well, 4, 5 is right about there. I'm going to call that 4, 5 on the unit circle, right? No, it's not on the unit circle.
No, it's on a coordinate plane.
Yeah, that's fine. Evaluate the 6 trig functions of theta. Well, first of all, let's draw the ray. Okay, that's theta. And now to figure out the trig functions of theta, let's drop a triangle. What's this side right here? What's the horizontal side of that triangle?
I think it's just
This is fine. This is fine. That coordinate point has dimension, or has coordinates 4, 5, right?
Oh, right.
So that makes that side 4. And this side 5. Now you can get all 6 trig functions. First of all, what's the hypotenuse equal to? That's the first thing you really want to solve for. We don't have theta, so we can't use any trig function to solve for that hypotenuse, but we can use Pythagorean Theorem. That's a right triangle.
Yeah.
So what's the hypotenuse?
5 times 25 plus 16.
Square root of 41. Give it as a radical always, not as a decimal. So that's that triangle, okay?
Yeah.
Now, tell me what the sine of theta is, cosine of theta, the tangent of theta, we'll do cosecant of theta, the secant of theta, and the cotangent of theta is what they want, all 6 of them. And we still don't know theta, notice, but we don't need to know theta. We've got a fully dimensioned triangle. So what's the sine of theta? And for my benefit, leave it unrationalized, just so we can go through this quicker.
Okay, it'll be
No, sine theta is opposite. You gotta remember SOHCAHTOA. I mean, you got no hope with trig unless you get SOHCAHTOA down in the primary part of your brain where you're drawing from. You don't want to mess these up. Sine is always opposite over hypotenuse. What is that?
It'll be 5 over 41, root 41.
Cosine of theta is what?
It'll be 4 over root 41.
Tangent of theta is what?
5 over 4.
Cosecant of theta is what?
Root 41 over 5.
Secant of theta is what?
Root 41 over 4.
And cotangent of theta?
4 over 5.
Okay. Now, you're fine with rationalizing these? I mean, your teacher wants them rationalized, you got to rationalize them. But
yeah,
you can kind of see the advantage of not rationalizing them.
Yeah.
Okay? Let's do another one. This time, I'm just going to draw the coordinate system. And I'm going to go to this point, 4, minus 1, right there. Okay? Now, I'm looking for this angle right here.
4.
So you're always, when it wants you to find, or when it says it's the terminal side of an angle, they mean it's always an angle when made with the x-axis. In other words, in some respects, when you're dealing with trig, all angles are measured counterclockwise. So we'd be looking at that big old angle there. But when they're doing these kind of problems, they don't look at that big old angle. They measure the angle clockwise. They just measure the angle with respect to the x-axis. Now, what's the next step? Let's label this point. That point is 4, minus 1.
So I can make it into a triangle.
Okay, and I'm going to use a dotted line. And let's see, give me the dimensions of this triangle. What's 4 and what?
1.
Okay, good. We don't need the minus sign there. It's a triangle, so it's just positives. And now what's the hypotenuse?
It's root 17.
Now, tell me what sine of theta is.
The sine is opposite over hypotenuse, so it's 1 over root 17.
What's the cosine of theta?
It would be 4 over root 17.
What's the tangent of theta?
1 over 4.
What's the cosecant of theta?
Root 17 over 1.
What's the secant of theta?
Root 17 over 4.
And what's the cotangent of theta?
The cotangent is 4 over just 4.
4 over 1, yeah, just 4, yeah, you're right. Okay, let's do this third one. The point is minus 2 comma minus 6. That's about there. Draw your ray. The ray always comes from the origin. Where's theta?
It's on the x-axis.
So this is theta.
Yeah, the origin.
In other words, it's the angle that is made with the ray and the x-axis. And it's the acute angle, actually. Because I also have this angle over here. But that's not the angle they want. That's not the one they want us to talk about. They're always talking about this angle, and those angles are called the reference angles. In other words, whatever your ray makes with the x-axis, that's the reference angle. So when I draw my triangle, just got to remember this. When you're in erase mode, it doesn't like you touching anything. So that's the triangle I'm going to draw. Dimension it for me.
That would be -6, -2. Or no, it would be 6, 2, not negative.
2 is which side?
The one on the x-axis. And then, yeah, 6 there.
Okay. Now what else?
Then it would be root 40 for the hypotenuse. Or, ray or whatever.
You can call it root 40. I don't care if you even simplify it. The point of the problem isn't to do that. Okay, now I'm a little puzzled. There's one thing we have not been doing, and I'm not sure we're supposed to do it or not. And that's putting a plus or minus sign on these things.
I don't think so. You don't really need it.
Well, let's do one of them that way. All students take calculus. Okay? In other words, we'll just pretend that maybe he wants it that way. Okay? So tell me what the sine of theta is.
The sine is the sine would be...
It's the opposite side to theta.
Yeah, it would be opposite over...
Which is what? No. Tell me what the opposite side to theta is.
2 over...
No, it's not 2. 6 is. In other words, the opposite side of any angle is if you take the two rays, extend them, the side that connects those two rays, that's the opposite side. It's never ambiguous. The opposite side of an angle is always clearly definable. Okay? So it's the opposite side over the hypotenuse. Now what is its plus or minus sign given that we're in the third quadrant?
Just be plus or minus.
No, it'd be negative, because sine is negative in the third quadrant. So it'd be -6 over root 40.
Okay, cosine.
cosine would be what?
Cosine would be negative 2 over root 40.
Correct. What's tangent?
It would be adjacent opposite. It would be negative 6 over. It would be 6 over 2, which is like it's 3 over 1.
Is it positive or negative?
Negative.
It's positive.
Positive.
We're in the third quadrant. Tangent's positive. And notice why. There's a reason it's positive, because it really is negative 6 over negative 2. And that's a positive number, negative divided by a negative. In other words, the x-coordinate actually is a negative 2, and the y-coordinate's a negative 2. And this, all students take calculus. You don't need that if you're going to use the reference angles always. You still there? Yeah, Sam, you still there?
Yep.
Okay, sorry. Something happened with my phone. Okay, so tangent's positive, and that's why. Is because the x-coordinate's negative and the y-coordinate's negative. Now, what is the cosecant of theta?
Root 40 over 6.
Negative root 40 over 6. In other words, again, the cosecant has to have the same plus or minus sign as the sine did. And the sine is negative in the third quadrant, so is the cosecant. What is the secant of theta?
Negative 40, root 40 over 2.
What's the cotangent of theta?
1/3.
Good. Excellent. So in case that's what they wanted, in other words, 23, first of all, let's talk about that for a second. That's in the first quadrant. So all 6 functions were positive there. So we did that one right for sure. But on 24, notice that's in the fourth quadrant. So the cosine is going to be positive, and the secant's going to be positive, but the other 4 trig functions are going to be negative on number 24. If they want you to put the correct plus or minus sign on it. And I can't really tell, given the instructions. Yeah, I can't tell whether he's figuring first, second, third, or fourth quadrant into that. My guess would be that he is. Okay, so I believe the way we did 25 was the way we should have done 24 also.
Okay.
All right. So is that it for this page?
Yeah, that's it for like the whole thing.
Okay, cool. Good to go?
Yeah, thank you.
All right, Sam. Have a good one. Talk to you next time.
Yeah.
Bye-bye.